Hello, my name is Kumara, and I'm from IIET-90, and my serial number is 191410317. And today I'm going to tell you about my coding program that I made with Qt Creator. And before I run the program and start to show you, I'm going to tell about the case that I choose, the topic, and I took it from this book, Operation Research Problem, Statement and Solution, and the writer is Paul Fowler, and also the others. Okay, so these books have so many cases about operation research, and uh, I really want to make a program that can actually solve the linear program model and using a graphic method. So I choose this case about production planning of wire manufacturer. So um, so when a wire manufacturer wants to product aluminum and copper wire, uh, so they have this this these constraints, and they want to know. So they want to know what quantity of each wire should be produced to maximize the profit, and what would the profit be. So uh, this case output is to find the quantity of each wire. So, for example, the aluminum wire is X, and for the copper wire is Y. So we need to find the X and Y based on the objective function, and also we need to find the Z, maximize Z, to find the Z by uh, by uh, actually calculate the calculate the x and y with the objective function. So I think that's all for the background. I think I'm going to continue to start the program. And okay, so this is the PT creator where I made the coding. So I'm gonna explain. Uh, so first, I import uh, actually 5 or 6 movie library to help me during create this program. So there is import sys, and then import Qt code, the UI widgets, UIC. Okay, for the 3 lines, the first 3 lines, it's for the basic coding. I use it, and then for the pub, I use it for the linear programming model. It can solve many problems of linear programming, and for the matplotlib and also the numpy to help me make a graph of the wire manufacturer. So later this coding will show the graph that will show the feasible area to find the maximum profit. And then in my coding there are two windows. For the first one is I call it window utama, and the second one is window kedua. So in the first window, there will be a click button that if I click, it will connect, and it will move to the second window or window kedua. And then in the in this main window, I also write some not basic, write some background for the case. So everyone will know about the program uh, when opening the main window. And then, okay, next for the second window, there also a click button. When I click, it will launch the uh, a function called hitung. So this hitung function will actually solve the problems and calculate the x, the y, and also the maximum profit. So okay, in this function you can see this is the input section where we can input all of the constraints. So there are KWH alu is for so alu is for aluminum, and chop this is for chopper wire, and for the KWH is for electricity, and this is hours, and this is raw material of chopper, and this is limitation of electricity and limitation of hours, and this is the profit of aluminum, profit of choppers. And then after we input all of the constraint, all of the data that we know, I want to display it in the second window, and this is the coding to display, and then I change the form to float because when we want to input, it only won't if it's on the string form. So next I will change the form into float, and then to start the API model. And then start from this, I use the library, pulp library, like this, pulp LP problem to help me to solve the problem. And then, okay, so the first one is I make there's a model variable that contain this, and I use it helping maximize because the output wants to know the maximize profit. So I use the helping maximize. And then there is x and y. X is the variable, y is variable, just like that. And then for the objective function. Okay, so this is the objective function. Mm, and uh, when we input the well, when we input the constraints, it also will uh, input in here. So for the objective function, for the constraint, it's already in based on the input when we input before. So and then this is model solve is to solve this linear program because we want to maximize it, and then this program will automatically maximize to find the profit, the optimum profit. And then to show the result, and uh, I use the pulp.value x to find the result, and I put it into a variable called result x. It's the same for the value y. I and also the value z. So there are result x, y, and z. And for the z, it's from the objective function that times by x and also times by y. Okay, and then for the final, I change the form again into the string, and then I want to display it into the in the label in the second window. So because it's only one is only capable if we is in the for string form. So the object I change into string because before it's float, and then and after and in this line it's already solved about the program, about the linear programming model is already solved. We already uh, find the maximum profit and also the x and also the y, but I also want to show the graph to so anybody who use this uh, program will found out um, the visible area that lead there into the production, the optimum production and optimum profit. So this is the coding show graph, and this for define equation. So in define equation, I use the np as numpy, so linspace to describe the x, and This for the x, the variable x, I usually in space, and for the y, it's the same with before. Uh, the input thing, I still use it um, to make the equation, and then um, there is y3, y4, and y5 to help me to create the graph. So PLT plot is to make the axis. So here there are two lines, the two main lines. So the first one is x and y, and the second one is x and y1. And then I make the first the first is the first constraint, and second constraint. The color for the first constraint is green, and the second constraint is blue. And for this is to make the uh, vertical line, and RXH line is for to make the horizontal line, and then PLTX line Y2 is for to make the horizontal line based on uh, Y2, which is uh, we're gonna input it later. And then so this is the title of the graph, water manufacturer profit graph, and then this label, X label, and the Y label, and I also put the legend, and the location is the upper right, and then this is where how I find the visible area by using fill between, and then it will fill the area that inside the line that already we uh, write here. Okay, so and then when I uh, write this with the LT shows to show the graph. Okay, so I think that's all for the coding, and I'm gonna tell you uh, about the flow chart of the program. So it's actually very easy. Just one you need to start the program, and then input all the parameters and constraints, and also you need to uh, you just need to press calculate, and the output will be displayed in the second window. So it's not as hard as uh, other programs or any another program, so it's very easy. So I'm gonna show you how I run this program. So first I'm gonna save this, and then I'm gonna run this program. You can see how I use this program. So this is the main window that I talked about before. There is the topic here, uh, and also the way I solve this problem. And this this paragraph is background for the program, for the case. So it will help the wire manufacturer to obtain the optimum profit by using linear program and creating a graph, and there will be a visible area also. So the program will start after we click this button, and okay, so I'm gonna click this button, start the program, and then the second window will show up. So here is the second window, and in second window I'm gonna put all of the constraints. It's like in this case, so we know that the program is work uh, work properly, and so the electricity required for aluminum is 5, the electricity test for copper wires is 2, and for the hours of labor for aluminum is 0.25, and then for this is 0.5, and then for raw materials available is 40, limitation is 500, And then for the labor hour is 14. Oh no, it's 60. For the profit for aluminum wire is 0.25, and then for the copper wires is 0.40. Okay, I'm going to check it again with the case. So I think it's correct. Okay, so the output will be the same as like this. So let's see if this program will work properly. Okay, so when I click the calculate button, it will show the constraints that we already input. It will show up here, and for the results will show up here. So the x it is 85, and the y is 37.5, and maximum profit is 36.25. So this is the result. Uh, the problems actually are solved, and also we can see the graph. And so the first constraint, the second constraint, so based on this constraint, and there is a y minus 60 is the red line, and then we can also see the feasible area. So this is the feasible area. So to gain the maximum profit is in between this area. So and turns out that the to for the wire manufacturer to that want to obtain optimum profit, uh, they need to uh, produce 85 in this point, 85 kilograms of aluminum wires, and also 57.5 kilograms of copper wires. And for the maximum profit that they will earn is 36.25. So I think it's not that hard to run this program. So I think, and then we can actually just close it. I think that's all for the program and the coding, and for the background. So this is the UE files. This is the main window, and also this is the second window, or window kedua. So I think that's all from me for my coding program. So if there is some mistakes, uh, help you. Okay, thank you. Thank you.